This is part 2 of week 3's lecture, and we're now going to move from the graphical method of adding and subtracting vectors to the analytical method. Many students find the analytical method more challenging initially because of the mathematics involved, but eventually they end up doing mostly analytical calculations. This is because the precision required to do the graphical method is more difficult. First of all, you must understand that every vector, A, can be divided into two subvectors, AX, which is its X component, and AY, which is its Y component. AX and AY combine together by vector addition to form A, and this forms a right triangle with A as the hypotenuse. The magnitudes of vector AX and AY are related to the resultant vector A by the angle theta, and this relationship is in terms of trigonometric identities. Therefore, AX is A cosine theta and AY is A sine theta. As you know, the sine of an angle is the opposite, which in this case is AY, divided by the hypotenuse, which is A, and therefore AY would equal A times the sine of theta. Similarly, the cosine is the adjacent, which is AX divided by the hypotenuse, and then rearranging the equation you get AX is equal to A cosine theta. We can use these relationships in our city block example to find the magnitude of the horizontal and vertical components of the vectors. In this case, the horizontal and vertical vectors can be found using the relationships that we saw. Also, you can work the other direction. That is, if you know AX and AY, you can find A and the resultant angle. And this is shown on this slide. A, by Pythagoras' theorem, is always going to be the square root of the sum of the squares of the two sides, AX and AY. Theta is going to be the arctangent, or tangent minus 1, of AY divided by AX, which is the opposite divided by the adjacent. Vectors A and B are two legs of a walk, and vector R is the resultant, or total displacement. And we know that vectors A and B added together by vector addition can form R. Now, with the graphical method, we would draw these to scale and use a protractor to get the angles correct, and then we would measure R and look at a protractor to see what the angle was. But you can also do this using analytical methods. And this shows you how to do that. You divide AX, or A, into AX plus AY, and B into BX plus BY, as shown in this diagram. You then find RX and RY by adding, excuse me for that, you then find RX by adding AX plus BX, and you find RY by adding AY plus BY. The angle can be found by AY plus BY divided by AX plus BX. This will be the tangent of the resultant's angle. So here's another example where you have vector A, which is 53 meters and at 20 degrees north of east. Vector B, which is 34 meters and 63 degrees north of east. And the resultant vector R, which is 36.6 degrees north of east. You can use analytical methods to find R. And let me show you how to do that on the next. Let's take a look at how we would do the analytical method practically. Vector A has a magnitude of 53.0 meters in a direction of 20 degrees north of the x-axis or north of east. Vector B has a magnitude of 34 meters in a direction of 63 degrees north of east. Using the analytical method, we can find the magnitude and direction of R. So we know that vector A has a, is divided into AX plus BAY, and then vector B is equal to BX plus BY. And so that we can say that RX, which is the X component of this resultant, is going to be AX plus BX, and RY is equal to AY plus BY. And then finally, we know that R is going to be RX plus RY. Okay? So, we can find expressions for all of these using trigonometric identities. We can say that AX is going to be A cosine theta, and BX is going to be B cosine the second theta, or A cosine 20 degrees and B cosine 63 degrees. Okay, so using that, we can put in the values for each of these. 53 cosine 20 degrees and 34 cosine 63 degrees, and that ultimately gives us Rx. Okay, we can also find values for this: A sine theta plus B sine theta, or 53 sine 20 degrees plus 34 sine 20 degrees, and that'll give us Ry. And then using Pythagoras' theorem, we can find the magnitude of R is going to equal Rx squared plus Ry squared, the square root of that, and the angle is going to be the arctangent, or tangent minus 1, of the y component, which is 53 sine 20 plus 34 sine 20, divided by 53 cosine 20 plus 34 cosine 20, and that'll give us the angle. So let's move back over here and look at the answer, which is shown right here. This slide shows the answers. You can see that AX is 49.2, BX is 15.4, so the sum is 65.2. AY is 18.1, BY is 30.3, and the sum is 48.4. Therefore, RX and RY are now known. Plugging those into the Pythagorean theorem, you can get R is equal to 81.2. And then using, again, RY as the side opposite and Rx as the side adjacent, the quotient of those two will be the tangent of the angle, and you do the calculations for that and you get 36.6 degrees. The subtraction of two vectors is very similar, except that you use the negative component of the vector that's being subtracted. So example, here we have A, and then we're subtracting B, and leading to the resultant of R. And so it's AX minus BX equals RX, and AY minus BY equals RY. So it's very much the same, it's just that the signs are changed because we're subtracting. So we're going to finish up this part by looking at this problem, and in order to do that, I'm going to get a new piece of paper here, and I'm going to also put this small so we can see it. And what we have now is we know R, and we know the angle of R. The R is the V total shown here, and it's, so I'm going to put it as R because this is what we've been doing before. So R, which is equal to V total, and from this problem it's 6.72 meters per second. And we remember that R is going to be equal Rx plus Ry. And the angle for R is right here. We see that it's the sum of 26.5 and 22.5. So theta for R is 49.0 degrees. Okay. Now, in order to find VA and VB, we're going to have to see that Rx is equal to AX plus BX, and Ry is equal to AY plus BY. And so that's going to be, so VA cosine theta plus VB cosine theta is going to equal Rx, and this is going to be VA times cosine, and theta for A is right here, 22.5, and VB cosine of 26.5, and that's going to equal to Rx. We also know that Rx is equal to R, which is 6.72 times cosine of 49 degrees. So now we have an equation that has two variables. This should be a B, by the way. Two variables and a result. We can do the same thing with Ry. This is going to be VA sine 22.5 plus VB sine 26.5. And again, over here, we're going to have 6.72 sine 49 degrees. Now we have two equations and two unknowns, and so we can, by algebra, get the result for VA and VB. And I'm going to wrap this lecture up now, so I'm not going to do the actual calculations here, but you can do those, and if there's a question, you can bring that to class. We will finish up. Actually, what I want to do is leave you with this problem to work on at home. It says find the north and east components, so that's the x and the y, well, the y and the x axis for the displacement shown in this diagram or this map. So take a look at this. I'll blow it up for you for a second so you can get a better look at it. But you see you have a distance of 123 kilometers at 45 degrees. And so the question is, what's the x component, or the east component, and the y component, or the north component for this? And I'll let you do that at home.